Dear students, today we will discuss about the concepts of heat and temperature. This topic is very important for an diploma student because these concepts are further used in their higher learning when they study about engines, about refrigerators or other such machines. And today we will discuss the basic concepts of thermometry, concepts of heat and temperature. So our topic is concepts of heat and temperature. So myself is Balwinder Singh from Government Polytechnic College, Guru Tegh Bahadurgarh, district Moga. So first of all, we will discuss about what is heat. As you know, when we stand near a fire, we feel hot. When we touch an ice block, we feel cold. So what is this hotness or what is this coldness? So this is given by heat actually when we are standing near the fire or we are touching the ice, some energy is flowing from one body to the other. Say when we are near the fire, heat is flowing from fire to our body, and when we touch the ice, heat flows from our body to the ice. So that is why we feel hot or we feel cold. So what is heat? Heat is a form of energy which produces sensation of warmth or coldness. Heat is a form of energy. Heat एक energy ਦੀ form है which produces sensation of warmth or ਕੋਲਡਨੈਸ, ਜਿਹਦੇ ਨਾਲ ਸਾਨੂੰ ਸੈਂਸਿਸ ਜਿਹੜੀਆਂ ਹੈਗੀਆਂ ਸਾਡੀਆਂ ਉਹਦੇ ਨਾਲ ਸਾਨੂੰ ਜਿਹੜਾ ਹੈਗਾ ਕੋਈ ਚੀਜ਼ ਵਾਰਮ ਹੌਟ ਲੱਗਦੀ ਹੈ ਜਾਂ ਕੋਲਡ ਲੱਗਦੀ ਹੈਗੀ ਹੈ, ਦੈਟ form of energy is called heat. So what is heat? This is the form of energy. Heat can be changed into other forms like heat energy can be converted into mechanical energy, in the case of engines. Heat can change give rise to temperature. Heat can change resistance of the metals. There are many effects of heat which can be observed in our daily life. So then we come to what are the units of heat. Units of heat. Heat or heat energy. One unit is called calorie. 1 calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade, that is from 14.5 degree centigrade to 15.5 degree centigrade. This particular interval is taken for rise in temperature, and 1 calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. 1 ग्राम पानी का टैंपरेचर 1 डिग्री सेंटीग्रेड ਵਧਾਉਣ ਵਾਸਤੇ ਸਾਨੂੰ ਜਿੰਨੀ ਹੀਟ ਚਾਹੀਦੀ ਹੈ that is called 1 calorie. 1 degree centigrade particularly it is taken from 14.5 degree centigrade to 15.5 degree centigrade. A bigger unit that is kilocalorie. It is written as KCAL. Calorie is written as CAL. Kilocalorie is equal to 1000 calorie. In other words, 1 kilocalorie is the amount of heat required to raise the temperature of 1 kilogram of water. ग्राम की बजाय इत्थे आप किलोग्राम ले लिए थ्रू 1 degree centigrade, then that heat is called kilocalorie. So 1 kilocalorie is 1000 calorie. As you know, kilo means 1000. It is the prefix which we have earlier studied in our first chapter, that kilo always means 1000. So kilocalorie is 1000 calorie. Again, 1 calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade, that is from 14.5 degree centigrade to 15.5 degree centigrade. SI unit. SI unit of heat is joule. As all forms of energy, they have the same SI unit, which is joule. Whether it is heat energy or electrical energy or mechanical energy or solar energy, all energies are measured in joule. This is the main advantage of this SI system, that it is a rational system. One quantity and one unit is used. So here also we have joule, which is the unit of heat energy, heat or heat energy. So 1 calorie and 1 joule, they are related to each other by the relation 1 calorie is equal to 4.186 joule. 1 calorie is equal to 4.186 joule. Approximately, sometimes it is taken as 4.2 joule. So this is how this calorie and joule are related with each other, and similarly 1 kilocalorie will be equal to 4186 joule. 1 kilocalorie is equal to 4186 joule. So, this is the SI unit of heat, which is called joule. An old system, old unit of our this heat was British thermal unit, which is called BTU. This is the amount of heat required to raise the temperature of 1 pound of water from 63 degree Fahrenheit to 64 degree Fahrenheit, that is through 1 degree Fahrenheit. The amount of heat required to raise the temperature of 1 pound of water from 63 degree Fahrenheit to 64 degree Fahrenheit, that is called British thermal unit. This is the system. The system is FPS. This is the old unit, which is now not in use. Nowadays we use joule or calorie. This British thermal unit is not now in practical use, but you must know one British thermal unit is equal to 252 calorie. This is how this British thermal unit and calorie are related to each other. One British thermal unit is equal to 252 calorie or 0.252 kilo calorie. So, this is the all the three units: calorie, joule and British thermal unit, which are used for this measurement of heat. Now, kinetic theory of heat. Kinetic theory of heat is each substance is made of small particles called molecules. In a solid, these molecules are bound, they only vibrate about their positions. In liquid, they are not so much bound, they can move but not free. And in gases, these molecules are free, they can move here and there. When some substance is heated or heat is given to a substance, whether it is solid or liquid or gas, the molecules, their motion increases, whether it is vibratory or it is kinetic. So, their motion increases and as a result their kinetic energy or potential energy increases. When we heat a solid, the space between the molecules increases and there is increase in the potential energy of the molecules. In liquid and gases, their motion increases, they move with greater velocity and their kinetic energy increases. their potential energy increases in solids, and this sum of potential plus kinetic is called heat. Potential plus kinetic energy of molecules, this is the heat. So, this is called kinetic model of heat, or heat, how heat is explained on the basis of this kinetic theory. So, this is the, if we take only liquid or gas, then we can say that heat is equal to total kinetic energy of molecules, which is equal to say half V1 square, half mV2 square, and so on. So, total kinetic energy of molecule is equal to heat. Then we come to and it is worth mentioning here that earlier this heat was taken as a fluid. There was caloric theory of heat, that it was considered as a fluid which flows. Fluid means anything which flows. So, this heat was taken just like a fluid. So, now this theory is not taken. Now, we have this kinetic model. Earlier theory, which was called caloric theory, this is not now used. So, this total kinetic energy of molecules is equal to the heat. More the kinetic energy of molecules, more will be the heat in the body. Another term which we will today discuss, that is the temperature. When we touch a body, we can just say approximately how hot it is. Just like if we have fever, ਜੇ ਕਿਸੇ ਨੂੰ ਬੁਖਾਰ ਹੋਵੇ ਤਾਂ we touch the arm of the patient and then we say, yeah, you have temperature. So, but how much temperature he has, that cannot be simply described. We can only estimate. Correct ਜਿਹੜੀ reading ਹੈ, the correct judgment ਜਿਹੜੀ ਹੈ that of the temperature can only be done with certain instrument. So, but before we discuss about that instrument, we consider that what is temperature. Temperature is degree of hotness or coldness. कोई चीज़ कितनी गर्म है और कितनी ठंडी है, उसकी कितनी डिग्री है, that is called temperature. Now, unit of temperature, you have studied in first chapter that SI unit of temperature is Kelvin, which was denoted by K. This is, you have studied in your first chapter. The fourth basic quantity after length, mass and time, with the fourth quantity which comes into picture, that is the temperature, which is used for discussing the concepts of heat and temperature, thermodynamics. And so, this temperature is very important for, because it is the fourth SI unit, which is Kelvin. Other units we will shortly discuss what are the different scales. Before that, we discuss the kinetic model of temperature. Temperature is average kinetic energy of molecules, which is say half mv1 square, half mv2 square, so on, half m v n square. If we take different masses, then we can m1 v1, m2 v2, then divide by total number of molecules. This is the total molecule, total number of molecules. If we divide the total kinetic energy by different by total number of molecules, then we will get average kinetic energy of molecules. So, this is very important, whether it is total kinetic energy of molecule or mean kinetic energy of molecule or average kinetic energy of molecules. Note that temperature is mean kinetic energy of molecules, whereas heat is the total kinetic energy of molecules. This is the main difference between heat and temperature. And kinetic theory of gases, kinetic theory of gases gives that average kinetic energy of a molecule is equal to 3 by 2 kT, where K is called Boltzmann constant. And T is the temperature in Kelvin. एक मालिक्यूल की एनर्जी जी है वो 3 by 2 kT होंगी है. दिस इज गिवन बाई काइनेटिक थ्योरी ऑफ गैसेस. नाउ डिफरेंट स्केल्स ऑफ टेम्परेचर. One scale is Fahrenheit scale, degree Fahrenheit. This was given by Gabriel Fahrenheit, the scientist which gave this scale. Every scale has 2 points. One is called lower fixed point, lower fixed point. Another is upper fixed point. This is normally melting point of ice at normal temperature, normal pressure 1 atmosphere, and this upper fixed point is boiling point of water. Now there are in every thermometer we have 2 points, lower fixed point and upper fixed point. In Fahrenheit scale, lower fixed point is 32 degree Fahrenheit. Upper fixed point is 212 degree Fahrenheit. Total divisions they are 180. One division is equal to 1 degree Fahrenheit. So in this scale you will have this 32 degree Fahrenheit, upper will be 212 degree Fahrenheit, and these divisions, total divisions will be 180, and one division will be 1 degree Fahrenheit. Total divisions, 180 divisions are there in Fahrenheit scale. This scale is used by doctors whenever we go to a doctor to check our fever. That temperature is given by this Fahrenheit. For example, normal body temperature is 98.4 degree Fahrenheit, not degree centigrade, it is Fahrenheit. The second scale is centigrade or Celsius scale, which is denoted by degree C. This was given by the scientist Andreas Celsius. Celsius is the name of scientist. First it was called centigrade scale. Now it is called Celsius scale after the name of the scientist Andreas Celsius, who introduced this scale. In this scale, lower fixed point is 0 degree centigrade, upper fixed point is 100 degree centigrade, total divisions are 100, one division is equal to 1 degree centigrade. In this scale we have lower fixed point 0 degree centigrade, upper fixed point 100 degree centigrade, total divisions 100, one division is equal to 1 degree centigrade. So, if we will have this scale, our lower point will be 0 degree centigrade, this will be 100 degree centigrade, total divisions that will be 100 divisions. So, in every scale you must know what is the lowest fixed point, what is the upper fixed point, and what are the total divisions, and what is the value of one division. A modern scale, which is the third, which is called Kelvin scale. This scale is given by the scientist William Thompson Kelvin, who was later known as Lord Kelvin, is the name of scientist who introduced this scale. In this scale, as we have studied that the temperature is Kelvin, which is denoted by K. It is not written as degree K, not written as degree K, it is simply K after the name of the scientist Kelvin. Now, it is introduced in the term of triple point of water. Triple point of water. How we define Kelvin? Triple point of water is the temperature at which all the three states of water coexist or are in equilibrium. Three states of water ਕਿਹੜੀਆਂ ਹੁੰਦੀਆਂ? ਇੱਕ solid ਹੁੰਦੀ ਹੈ ice, liquid ਹੋ ਗਿਆ simple water, and gas which is the in vapor form. So, the temperature at which all the three states coexist, that is called triple point of water. Its value is 273.16 Kelvin. So, this is how 1 Kelvin is defined as 1 over 273.16 of triple point of water. In your first chapter, if you have the study about definitions of various meter, second, kilogram, Kelvin, then you must have studied that 1 Kelvin was 1273.16 of the triple point of water. So, this Kelvin is defined as in term of triple point of water, which is the temperature at which all the three states of water coexist. Now, in this Kelvin scale, lower fixed point is 273 Kelvin, upper fixed point is 373 Kelvin, divisions total are 100, one division is